to this computer. There we go. Thank you. So these numbers could be anything. They could be 100, they could be 50, they could be 7.62. Whereas with proportions, you always had a number between 0 and 1 or 0% and 100%. So that's a thing to watch out for in this first step. Just kind of keeping in mind that you could have wildly different numbers. Remember, the other thing that's different is how we identify the requirements to do the test, and that's whether we have at least 30 in our sample size or we have a normal probability plot that's approximately linear. The formula is different. And the other thing that happens here with that is that sometimes we have data and sometimes we do not have data. With the proportions, we always use the summary, right? We always, we never use data with the proportions. So this time we might have a column of numbers that we work with. The other thing to note is that we're using the t-stats as opposed to proportion stats. Everything else we do with the hypothesis tests are the same. What it means to make a type 1 error, same thing, it's alpha. The smaller the p-value, the more statistically significant the results, if they are statistically significant. How we state the conclusion, everything else is the same. So here comes a problem. This is page 696. I think I'm just going to give you 5 minutes to work on the first page. We've given you an output. Make sure you read here, and you're just going to fill this in, see how it goes. If you get stuck, let's talk about it. Yeah, so get going. So timer for 5 minutes. Okay. What'd y'all say for the symbols of the hypotheses?
I just copied down the one sample T hypothesis test. Yep, right there.
Right, nice. So this one, it's handed to you. Now, if we're gonna say it in words, you can take it right here. The average monthly cell phone bill in the US is this. So the claim here is that the average monthly cell phone bill is different than the 127.37. That's our claim. Okay. So what type of test? Oh, right. Let's see. Match the symbol with the name of it. Okay, two-tailed, right? That's pretty straightforward. What's the population size? Anyone find that?
The
It's
200.
260 million.
Never mind. That's the
Yeah.
big
260
N.
million.
Good. That's the big N. Nailed it, y'all. So, right, be careful keeping track of population size versus sample size. So whoever said 30, you're right about that. Degrees of freedom, just remembering that you can read that, 29. Now, if you're wondering where did everyone get the sample size of 30, remember degrees of freedom is n-1. So if we know the degrees of freedom is 29, add 1 to it, we get 30. This is a reminder. Do you know what these symbols mean?
I do, but I have no idea how to find them. And this is what tripped me up. I'm like, I know this.
Right here.
How do I not know this? Because SE is standard of error. Okay. And then X bar is X bar mu.
X bar is sample mean.
Okay. So X bar is 133.6003, whatever.
You got
33.
it. Yeah. But all this is, well, there's a formula for this. This is like the sample standard deviation divided by the square root of n, but you don't even need that because we handed it to you. StatCrunch gives you the standard error. So in this case, all we wanted you to do is recognize that this meant the standard error of the sample means, which is the 3.256, blah, blah, blah.
When
Let's
you
see.
go into StatCrunch, when it says standard deviation, is that where you put the standard error?
No, that's where you put the standard deviation. So in this case, we weren't given the sample standard deviation. I'm guessing we might have to calculate it later. StatCrunch uses the sample standard deviation, the sample mean, and the sample size to calculate the t-stat, the p-value, and the standard error. We know how to calculate it using this formula back from chapter 8. So I think, Peg, to your question, what you enter, well, let me say it this way: we're never going to tell you the standard error outright. Like it's never going to be in the problem.
Okay. I think when I go into StatCrunch, I either am not going in the right place or for some reason I don't have the right information. So that's what really is throwing me off.
Okay, good. We'll practice that. We'll
Yeah.
at this point we don't need to because someone entered the information for us.
Right.
So
right.
that's the next problem.
Okay.
Okay, so good. Anyone? This was maybe too straightforward. How did anyone keep going? Or should I give us 5 more
I
minutes?
got the whole, I did 10.3 worksheet 2 and the next one as well, 10.3 worksheet 3. And let me tell you what, you guys, I just want to say, I missed an entire week of lectures. I have been busting my ass. I have not eaten turkey or pie or anything, but I think I might have a handle on chapter 10.
Hey, worth it. Nice. Okay, so
yeah, I went all the way through.
how about the rest of you? Good, Peg.
I still need time on the second page.
Okay. Let me give you 5 minutes on this one. Remember, you're still pulling stuff from up above. You're still using this as your output or as your information. So let's do 5 minutes.
Yeah, also when we get to G, I know I'm wrong. Like I said, I have way too many zeros. So I might have worked ahead, but I know
Sure.
there's no way there's that many zeros.
All right, we'll check it. So let me give you all 5 minutes and then we'll go over it. Set a timer for 5 minutes. Taylor, is that good for what you need to see?
For normal on this one, is it the n times? Oh, wait, no, it wouldn't be that. No. Oh, n greater than 30. Okay.
Nice, good. Turns out it's greater than or equal to, so it works. There we go. Okay, how'd we do?
I'm just stuck on number, like the third step. Oh God, we don't even have to do that, do we? I didn't read the directions.
No worries. Hey, that feels good.
But we have
Um,
to do the third step in order to do the fourth, fifth, and
Fourth,
sixth. step.
yeah.
Here's step
But-
3.
Oh God.
Right,
So,
it's given to
okay,
you.
okay.
Go ahead.
No, I was just like, I was trying to do it and I was like, where's the standard deviation? So
Not
we
given.
just, yeah,
Yeah.
okay.
You could calculate it from here, and then you could type that in with your 127.37, and StatCrunch will spit this out again. Or something really, really close, depending upon how you round, what you round your sample standard deviation to. So one of the things with the independent, remember, you got to show that the sample size is less than or equal to 5% of the population. You don't actually need to do this calculation. You just need to state, just write down the stuff. Like, this is 260 million. Like, that's, yeah, good enough, right? You don't need to calculate 5% of 260 million. So that, and sometimes we don't give you the numbers, and you would say all cell phone users. In some cases, I'd almost prefer to see that you could put that together than the fact that you could find the actual number. But when they give you the actual number, go for it. If you wanted to do the calculation, you could do 0.05 times 260 and just show that it's 13 million. And that's fine too.
That's what I did.
Yeah, that's
Okay,
also.
now tell me about normal.
So normal is just that n is greater than or equal to 30, so it's done.
Well, it's 30 and 30, right?
Well,
Because
is
n
30,
is 30.
is 30 equal to 30?
Well, it's right.
So it's met. We're good. If it had said greater than 30, you'd be right, Peg. We'd have to think about that. But because of this equal to sign here underneath the inequality, if we have 30 or more, we're set.
Yeah, I thought, okay, so paranoid me, I'm like, no, they're not going to make it that easy that it's just like 30 greater than or equal to 30, are they? So, no,
Well,
I
and
got it.
it may seem arbitrary, like someone just made it up, but there is some theory here, some calculations that have been done that leads us to this number of 30. So we don't go into that because it involves some calculus and things that's beyond the scope of this class. But it really is just, do you have 30 in your data set? Which is that easy. Now, remember, you might then be thinking, oh, but I had to do this calculation back over here. Well, that's because it's for proportions. So it's a different parameter that we're dealing with. And I think every time I talk about this, I probably sound like a broken record. I'm like, hey, this is the one students mess up. So keep that in mind. Okay. Steps 4, 5, and 6. Remember what they are. Step 4 is, let's just draw the graph of the output. So we know it's this one, and we're just putting in the stuff we have here. Step 5 then is, are we going to reject HO or not? So we're comparing the p-value to alpha. So is 0.0656 less than 0.05? I'll write this one down. I'm not going to write 4 down.
No, so we do not reject.
Got it. Now, I know just about every problem we've done, we have failed to reject HO. Don't think that you always fail to reject or one way or the other. Each problem is its own problem. They're independent of each other. Okay, so key thing here that you need to note, when it is not true, when the statement is false. Here we're looking at 6. The question is 6 less than 5? It is not. So we do not reject HO. And then the conclusion, right, is there is not enough evidence to support the claim that the average monthly cell bill in the US is different than 127.37. In other words, this parameter that was established back in 2020 based on this study by CNBC seems to still hold. This appears to be the mean cost. This is an interesting question here. Are these great practical real life significance? The results are that we have no results. So no, there is no significance. But even if there were significance, even if we were able to reject HO, it's really difficult to claim practical significance because you kind of need to be an expert in the field and you need to know what the amount of difference actually is. So like if we had found that maybe the mean is actually 90 in our sample, that doesn't mean that the population mean is 90. It just means there was evidence that this is different and our sample suggests it's lower than that. So your answer for this type of question is always, we probably need more knowledge to know whether or not things are practical, or we need an expert to look at the results and talk about it. Okay. Now let's do an actual test from start to finish. So number 2, you're doing your 3 things, your 3 conditions. So run through those real quick. And then you're going to do your whole test steps 1 through 6 here. Notice this is a data set. You are going to have to type this in. So I will at least pull up StatCrunch. And I'll get that typed in while you all are working and we can care thing. So let me give you 5 minutes and I'll check in. What I want to know in the next 5 minutes is if you can get A and steps 1 and 2 done. And then we'll take a look at step 3 together. Set a timer for 5 minutes. Cool, Peg, no worries. Okay, so it looks like I can just share my link to the data and you will get it. So I dumped my link in the chat so that you all don't have to type the data.
I got an error when I clicked on that. It says the following action could not be completed.
I got that too.
And which, what did you click that you got that error?
The link that Eric sent in the chat.
Oh, I entered all my numbers manually, so I don't.
Sorry, Al. Well.
I
uh,
answered everything manually, so I didn't go by it.
Yeah, I was just trying to save people some time, so nothing to worry about. I wonder if you copied it, because it doesn't work. It works in Chrome. I don't know. It might just be faster to just type it. Oh, that's annoying. Or you could, yeah, that could be faster. Or maybe if you search data sets and number 2. Nope, that's not gonna, no, that's probably just gonna be faster to type it. Sorry, Al. It works in my Chrome browser, but it didn't work in my Word Edge browser. Okay, let's look at how'd you do on C1, C2, C3?
Random is given, independent 22 is less than or equal to a 0.05 n because it's 22 by, less than the solution is 250. Normal 22
Oh,
is
hang on.
not.
Let me make sure. Let me step back here. Make sure you said, let's see, 22. I'm with you on the sample size is less than or equal to 0.05 times what? I missed that part.
0.05 capital N.
So do we know what capital N is?
I just
Yeah,
put all
it's-
JC students.
Love it. We can use the 5,000, or we could say all JC students, either way. Yep, either one. Good. Okay.
Okay.
Sorry. Keep going. What was your last one for normal, Peg?
Well, I used that for the 5,000, but 22 isn't greater than or equal to 30, but normal probability plot distribution appears approximately linear.
Good. That's it.
Oh my
So-
God.
The normal probability plot
Appears
is
approximately linear.
approximately linear. Done. That's how we know this is normal. Yep. We could also mention that it has no outliers, but it's okay. We see that. So I'm not worried about that piece. Good. Okay. So the next thing then is what are the null and alternative hypotheses?
Mu equals 3.15 and mu is less than 3.15.
Okay, I just want to highlight the word that gave us less than right here, lower than. If anyone's wondering where we got that, less than, and here's the 3.15. Now, how did we know this was the parameter? It's the only mean given, right? We don't have a sample mean because we're going to calculate it from this data set. And we don't have a sample standard deviation, but we're going to calculate it using the data set. Excellent. Okay, step 2. Did everyone get that one right?
Yes, but could you just hold on and go back to what you wrote on that table? Because that's where I'm screwing up on the X bar and S. So just stay there just for a second so I can write this down.
Well, all I wrote is that we don't know it. So I don't know if that's helpful.
It is helpful.
Okay, good.
Thank you.
Yep. We get this in StatCrunch, and really to get the sample standard deviation, to actually know it, we have to do like the summary stats, but we don't really need that. I'm not going to require you to do that. Because in step 3, we don't enter the standard deviation or the mean. We have the table. Okay, cool. Did we get alpha?
Yeah, it's 0.05.
Nailed it.
No,
Okay.
yeah, 0.05.
Yep, because of this. Good. Just a reminder, I know we've said it once before, but it's also helpful, I think, to repeat things. Alpha and level of significance are the same thing. Okay, so then we do step 3. Now, I'll just show it to you. We'll have another one where you get to do it yourselves. As a reminder, you don't have to memorize what I'm showing you here. You just have to know where to read it. It's right here. So if available, enter raw data into a column, check. Then go to stat, T-stats. Excuse me. For chapter 10, we're doing 1 sample. For chapter 11, we'll be doing 2 sample and paired. But for now, we're doing 1 sample, and we're doing it with data because we don't have the summary stats, even though we could generate them if we wanted to. So when you do it this way, you have to select the column that you're working with first, and then you have to make sure you're doing a hypothesis test. Remember, chapter 9, we clicked confidence interval. So we do use this. We do confidence intervals, but that was before. Type in our 3.15, of course, we put in our less than, and that's all we need. That's it. I have often included the p-value plot. This is step 4. It's not needed, but if you want to see a computer generated step 4 graph, you could include that. And yeah, that's it. Compute. And there it is. So here's your standard error. If we wanted to, we could use that to calculate the standard deviation. We don't need to. Here's the t-stat. Here's the p-value. If I click this over button, because I clicked p-value plot, there's the p-value. There's the graph of the p-value. Not very pretty. So what do you need to write down for step 3? Cindy, you correct me if I'm saying things, if I'm not saying it right, but what I'm asking, what I think we're doing, or you all tell me if you've been doing it differently, is that you're going to write down the formula you're using. So this is the T naught value, which is equal to this formula, x bar minus mu naught divided by the standard error of x bar. And then if you're wanting to do the substitution, you can write down your x bar, 2.90. You can write down your standard error of the x bar, which is the 0.11. And I feel like that's it. And then the number. Oops, I should do 3 decimals here. Does that feel like what you all been doing?
Yes, we just.
Okay, so yeah, keep writing that because I'm coming up like just a little behind.
So
2, 2,
what
3,
we could
9.
all do is double check.
Oh,
our
no,
data.
I'm not. No, I'm not. It's a rounding error.
Okay, nice. Yeah, I guess I should have asked, does everyone have the same output? Because if we have anything different, then either I typed in something wrong or you all typed in something wrong. Cindy, I missed what you said.
Perfect. What I also have them do in step 3 is just write down what the p-value is because they'll need it for step 4. And I said, while
Right.
you're right there, just write down what your p-value is.
Love it. I agree too.
A question. So do you want our p-value on the top of the arch or if it goes, you know, a left tail or a right tail on either side or the top of it's a 2 tail? Is that how you guys want it?
So, well, so The only thing,
Like
only
you
place
see
where
it right there.
right, like you can just copy this.
Okay.
That's perfect. The only
Okay,
place
okay,
where it
okay.
matters
Cool.
is that in the two-tailed, the p-value is the sum of the two areas.
Right,
Whereas in the other two, there aren't two areas, right? So if you wrote, say, like the p-value, if it was two-tailed and you wrote the p-value over here, it makes it look like you think all of
Mm.
that area is right here when it isn't. It's in between the two. If you divide this in half, you get the amount that's there. So yeah, you can just
Well-
copy the picture.
okay. My habit has been, and this is why I'm asking, putting the p-value on top of the arch and then drawing an arrow. And I don't think that's right.
It doesn't really matter. It's like where
Okay.
where do
I
you
know
post
where
it?
it is. I mean, I
Right,
should.
that's what matters.
Okay.
Right. I usually put it next to the area when it is a single tail. So like this is how I do it. And then when it's two tail, I put it up on the arch with the two arrows. Okay, so then step 5, you can see I'm totally running out of, why am I doing these? I was supposed to give you all time to practice this. We'll do it on the next one. So step 5, we're looking at, is the p-value less than alpha? And what did you all think?
Yes.
Good. The conclusion is?
There is
Reject
enough
ahead.
evidence to support the claim that the average, where are we, GPA?
Yep, good.
GPA is less than 3.15.
That's it.
All
I'll
right.
type it at the top here. Step 6. There is enough evidence to support the claim that the average JC GPA is less than 3.15. Yep.
Just a quick quip. I am above average.
Okay, nice. Love it.
By many standard deviations.
Okay. Okay, so questions. Did anyone get lost in any of these pieces?
I keep getting a little lost in step 3, but it's just making sure that I'm doing the proper formula for that particular story or whatever.
Gotcha. Well, let's
I
try
get
one.
lost. I get
Go ahead.
lost in step 3 too, because I don't know what everything is. And sometimes I think I guess and just get lucky. So step 3, yes, is still, I'd like to go over that again.
Well, let's do this one. Let's go to page 701. So this is the next worksheet. I think we've done everything for this worksheet. This worksheet is totally done. So let's go to the number 7. In this one, what do you notice right when you look at the problem? What do you notice is different than this problem than the one we just did?
Let me pull it out. What page is that?
Oh, I'm sorry, page 701. And just take a second, just look
For
at it.
me,
Don't even-
it gave us everything. I'm like,
don't even
yeah,
read it.
give us everything.
Yeah, but so I want you to see the one, like right when you look at the page, just kind of ignoring the words. What's the difference between this one and the one we just did that should jump out right away?
Well, that was, one was a table and one was a word
That's it.
thing.
Okay, so one had a table and this one just has words.
Right.
You should start getting in your mind that when you see a table, it's with data. When you see a bunch of words, what you said, Peg, was totally correct. All
With
the information is
summary.
there. Yep,
Okay.
you're going to do it with a summary. Okay.
Yeah, okay. But let me just back you up, because I think that's for me, anyone, and I don't know what about anyone else, but the tables are tricking me up because I don't have the information. And I know how to get it, but maybe I don't have all the information to get what I need to get.
So if it helps you, if you prefer to have summary, you can do what you did in chapter 3, and you can go to stat, summary stat, columns, and you can get the mean and the standard deviation. Where is it?
Oh my gosh, Eric, really? That will help me
Oops, we have
because
to
that's
select it.
how I
Yep.
was thinking. I'm like, I think I'm sorry,
So-
everyone, but I mean, that's how I need to go back there and go, hey, I need this because I can't find it real quick right now. So I won't
Well,
take your time, but thank you for that.
It could be, so it could be, Peg, though, if you're doing the with summary thing, then you're always looking for these 3 things, which is why you're like, I'm guessing at what needs to go in here when you have a data set. If when you have a data set, you do with data, it doesn't ask you for that at all. It just says, hey, where's your columns? Bam, what's your stuff? So
I know, but I mean, I guess, is that okay? I think that's really
100%.
where,
Yeah.
okay,
I
okay,
expect, when I
okay.
give you data, I'm like, oh,
Okay,
don't do
okay, then I have just
nice.
overcome a hurdle because I'm like, this is not matching. All right.
Yep.
All right, let's go. I'm ready then
Okay,
now.
so let's do
'cause
it.
I
Go,
think I'm
you got
okay.
it.
Let's do it.
You know that you're doing with summary. Actually, I shouldn't show that because what you need to practice is making sure you can find all the pieces you got. Okay, so I will be quiet and let you all work for at least 5 minutes. I'm going to check in. Let's make sure within the 5 minutes, the goal is to try to get at least step 1, 2 done and maybe have questions on 3. But I'm going to give you maybe another 5 minutes beyond that anyways. Set a timer for 5 minutes.
So Eric, would we use the where it says assume the mean is 1.8, or would we do the 0.96 because that's right next to the standard deviation?
Great
Because it
question.
says right here, assume the mean is 1.08. So that's what we would do, the HO equals.
So, right, so the way to tell is, is this a population value here, or is this a sample value?
Assume the mean. Oh, so that's the population.
Good, because
So
of the
we want
implied
the
all.
0.96.
No,
'cause
that's
that's-
what you want from you, not 1.08. Because you want, in step 1, you want the population value.
Okay,
And we know that's population value because of the implied word, all 3 to 6 year olds.
right.
Here, it's a sample of 35 3 to 6 year olds had this. And it also says sample mean of meaning X bar equals 0.96.
0.96. Okay. So
Good.
that's what we would put into StatCrunch later.
Yes, yes, you're
Okay.
putting this in for sample mean in StatCrunch, and you're putting this in the hypothesis step for StatCrunch.
Got it.
Good.
So X bar equals P hat. Cause I had P hat at 0.96 and you just put X bar at 0.96. And I'm
So-
like,
Because
because my
it's a
trouble
mean.
is trying to find X bar. That's my struggle.
So P hat goes with proportions and it's a sample
Right.
proportion. And these are not proportions, these are means. So there are no P's in question 7. Where they're similar is P hat and X bar are both sample values calculated from a statistic. So we call them, or calculated from a sample. My goodness, I'm just like throwing words around. So we call X bar and P hat statistics.
So when I put P hat equals 0.96, what I needed to do for this problem was X bar equals
Yeah.
0.96.
100%. Yep. Good.
Okay, so this changes everything. Thank you.
You are welcome. That was 5 minutes. Let me at least write down step 1. So I'm going to the can you conclude part where the claim comes in and it says lower average. So I want a less than symbol here. I'll also write down step 2. Did everyone agree that this is 0.05? And I'll at least write down the formula.
Yes, and yes, on step 3.
So should I run the calculation in StatCrunch? Has everyone got the stuff?
Ready?
All right.
Yes.
Okay, let's run it. So stat, T-stats, 1 sample. This time it's with summary because we have it. So I've got my X bar is 0.96 from the problem. And sample standard deviation, that stands for S of 0.28. And then in here, we need the sample mean, the sample standard deviation, and the sample size. Did I write it down? I didn't. Here it is, n equals 35. So be careful. I have found myself making this mistake, not reading carefully what came first, right? So it's always mean, standard deviation, and then size, and it can be easy to, like, I don't know, mix them up sometimes. So just be mindful of that as you're going through. I don't know if it's worth saying, but it's a mistake I've made. So I put in the sample values that were given to us in the problem. I'm now putting in my mu naught, the believed value of the parameter, and changing my inequality sign. That's another place that can easily get us. And that's it, and compute, and away we go. I can click this to include the p-value plot if I want. Again, that doesn't really matter. And here's our stuff. T-stat and a p-value. So let me give you 5 minutes and you all see if you can't get steps 4 through 6, unless you're all done.
Can I ask a question real
Oh,
quick?
most definitely,
Does-
please.
Does P hat equal X bar?
No. P hat is a totally different statistic when only used when working with proportions.
Because I got P hat equaled 0.96 and you got X bar equals 0.96. That's why I'm wondering.
So if it's just a, well, when you type
Probably
in,
a screw up on my part somehow, but I mean,
Yeah, I
I
think it's
got
just-
the
it
right
was-
answer, but I got the wrong symbol.
yes, that's it. You're just writing down the wrong symbol. When you read the word sample mean,
Cause I got everything else.
yeah,
Right.
it's just using the wrong symbol. Sample mean is an X bar. Sample
Okay.
proportion is P hat.
Okay, thank you.
You're welcome. Okay, so let me give you 5 minutes to do steps 4, 5, and 6, just in case you need it. If you want to type in chat when you're done, if everyone is done earlier, we can talk sooner. It's up to you. So I can for 5 minutes.
F2.
Are you sure we're trying this one? Yeah.
Okay, that was 5 minutes. I'm just gonna skip to the step 5. What did you all conclude at step 5?
Do not reject.
Do not reject. Did you have a p-value of 0.008?
Oh, yeah.
And an alpha of 0.05?
So that's a reject.
Yeah, that's a reject. Nice thing is it's an easy fix. Just erase the not word in the next sentence and you're good. Does everyone agree with that? It can be a little tricky checking these. I'm totally with you. And what you do is you note the first non-zero digit that they both share, and that happens to be the second one. So the question you could ask yourself is whether or not 0 is less than 5, which it is. So we reject. What's our conclusion? There is significant evidence to support the claim that, and then copy and paste all of this. Young children in high pollution community have lower average FEV1 levels, period. So according to this, children have, oh, I've seen these things. Like you blow in that little thing and there's this little tube and it pushes it up. Yeah, so this is suggesting it's bad to live in high pollution communities. I mean, go figure. Is anyone stuck on any portion of this? Did anyone get lost anywhere? I've left out things, like I haven't written everything down, but are you
I'm
starting
good
to?
with it.
Okay, good. So let's go back and do one more. Okay, so I'm gonna give you 5 minutes. Try this one. So this is page 700, one page back. Another hypothesis test. What jumps out again right away? What do you see just looking at the problem?
Average.
Good.
And it's a data, like you're gonna do with data and stuff with summary.
That's it. So we're, instead of what we just did, where we were entered in the 3 summary values, we're going to type in our data, although there's this source thing. Let me see if I can open this up. This may not help you all. It might just be faster to type, but no, I don't want to leave. Copy link, paste. That's not helpful. Okay, never mind. Okay, never mind. We just got to type the data. All right, so I'll give you 5 minutes. I'll type the data. Did you all ever get the link to work? I probably didn't.
No, I never did. I just ended up typing it.
Okay. Well, I won't even share my link.
Same, me too.
All right. I'll set a timer for 5 minutes and you all try it out. Set a timer for 5 minutes. Okay, how we doing?
I think I'm ready.
I think I'm ready to.
Okay. So, yeah, C1, C2, C3, it's approximately linear because this is normal probability plot that looks approximately linear. So it's normal, right? Blah, blah, blah. I'm blah, blah, blind, but is everyone, I haven't had anyone ask a question about these in a bit. So are we happy with those?
Yeah.
Okay, so now the big one. What did you use for your number in HO and H1?
139
Good. In some ways,
and it's
The-
less than.
oh, let's see. How do we know? A researcher thinks the calorie count is lower. So here we get the claim part. And lower than this, so less than 139. Excellent. Let's jump to the T-stats, one sample with data. Variable 2, got my 139. Man, all of these problems were less than. I actually couldn't find any greater than ones on these. Just in case we want it, compute. And did you get step 3? I'm just going to write down the p-value and the t-stat. Negative 1.618 and the p-value of 0.0633. Is that what we all had, or did you all have something different? I could have made a mistake, so it could be my fault.
That is what I had.
Nice. Okay, there's no way we all made the same mistake unless you copied from my screen when you were typing.
I had
Okay,
to click back and forth, but I have it.
nice. All right, as long as we all have the same thing. Good. So what did you for step 5? Did you choose to reject or not reject? What'd you
I
say?
said reject H. Oh, wait, I'm sorry. Not reject. I was looking at the wrong page. Because point, like the 0.06 is greater than 0.05 because you just look at that second place.
Love it, love it. Okay, so there's not enough evidence to support the claim that the mean number of calories in a chocolate chip cookie is less than 139. Okay, so let's look at this one. What did you say for type 1, type 2, or correct decision error? Remember, one of the ways to keep track of this is to make a type 1 error, you have to have rejected HO. To make a type 2 error, you have to have not reject HO. Like that's the only time that those two can happen. That's one way to keep track of it. And then correct decision, it could be either one, right? That's the tricky one. So what did you say? Did we make a type 1 error or a type 2 error? Or did we not know on that one?
My daughter was having a fit. I just took her to the bathroom. I'm back. Where you at?
No
See?
worries. So we're looking at the last question and we're trying to decide, let's suppose that the chocolate chip is actually 139 calories. Let's say that this is true. Did we make a type 1 error, a type 2 error, or did we make the correct decision? So type 1 error only occurs if we rejected HO when we shouldn't have.
So it was a type 2.
Type 2 error only occurs when we did not reject HO when we should have.
I
Oh,
wrote down type 1 because that's like a false positive. That's kind of like what I wrote down in my notes. Like type 1 is a false positive and type 2 is a false negative. So since they I don't know.
That's not
That
bad
was my
thinking.
thought process.
No, I'm glad you shared that. That's good. That's not terrible thinking. So I guess the thing here is, if what we've been told is that in reality, HO is true, and what we said is there wasn't enough evidence to reject HO.
So then we made a correct
We
decision.
made the correct decision. Based
Okay,
on this
so if
data.
we reject HO, then it's some sort of error, but if we don't reject it, then it's a correct decision.
No, it's not that simple, unfortunately.
Okay,
So it works like
That's
this.
where I'm getting confused too, Reagan.
So there's our decision and there's reality, right? So reality, if HO is true, like if in reality HO is true, we could make the correct decision or we could make a type 1 error. So the only way to make a type 1 error is if the null hypothesis is true and we reject it. So then for a type 2 error, like if in reality the null hypothesis is false, if we should have rejected it and we don't, then we either made a type 2 error or maybe we should have rejected it in our decision making and it's correct. So there are 4 possibilities, 2 of which are the correct decision, right? So your job is to first figure out what is the statement that they've given you. What are they telling you about the null hypothesis? They're either telling you it's true or it's not. Then you look at what decision did you make? Either you rejected or you did not. And from there, you can just determine which is the correct one. So if I were to use that, I was told that, let's see, I was told that HO was true. So I'm in this column. So I know I'm here. And then we would look at, well, what decision did we make? We said, do not reject. So I can go to my decision column and say, this is the one I did. Oh, that means I made the correct decision. Had I rejected in this scenario, it would have been a type 1 error.
Oh, okay. Oh my goodness.
That's how like using the table can be super helpful. Just lining up what you know. What did you do? Okay, which decision is it? Cool. Okay. Boy, we've just been doing it and doing it. The rest of the stuff, these questions 1 or 2 are old, 1, 2, 3, and 4 are old school questions about the relationship between the p-value, statistically significant, and the critical and the test statistic. So let's write at the top of our paper real quick the overarching thing we know, and that is, first off, when thinking about p-value, we're comparing it to alpha. If that's true, we reject HO. If that's true, when we do that, what we're claiming is our results are statistically significant. Right? Those 3 things are all essentially the same concept. They're essentially saying the same thing. We can pick any one of the 3 and talk about that. The other connection here is that the lower the p-value, then the more statistically significant. We had talked about that in 10.2. We'd kind of written that sentence down. So if we make a lower p-value, we're increasing our statistical significance. Remember that practical significance is never guaranteed. So if you look at number 1A, the p-value less than alpha implies the results have practical significance. That's false. Practical significance has to be determined by how much of a difference is there, or how much lower are the results, or how much higher are the results. And that depends on context. Like if you're talking about reducing death rates, practical, like reducing 1 death to me is practically significant, right? Like saving 1 life has practical significance. But when talking about, say, the federal budget, or how the United States allocates its money, saving $1 is not practically significant. $1 is basically $0 when you look at the trillions of dollars of money that is spent in a year. So one thing we could say here is practical significance depends on context. Okay, this is another nice one. I know you did in the notes with Cindy in 10.3 that if you decrease alpha, that means you're increasing beta. It's like this little curly B. And remember, beta is a type 2 error, alpha is a type 1 error. Level of significance is alpha. So, and level of significance is the chance of a type 1 error. So this one's true. Lowering the chance of a type 1 error increases the chance of a type 2 error. There's that seesaw kind of effect going on there. Okay, we've got 30 minutes. I want to leave question 2 and 3 and 4 for you to think about. And what I want to do is go to the chapter 10 review. And I'm just going to randomly pick a problem. And I want you to figure out what the problem's asking you to do. But before I do that, let me give you kind of a thought process for chapter 10. And I'll repeat this. We'll rewrite this again for chapter 11. So here we go. Chapter 10, problems. How to solve. So what I said before, let's do it this way. How to solve a problem. The first thing you need to know is what parameter. To me, this is the most important question for any problem. What parameter are you working with? Because it determines all the other special sets of words and formulas and things that go with it. So you have a 50% chance of guessing it right. You have a 50% chance of having the chance to get the problem right or losing all the points. Because if you get the wrong parameter, you really can't do anything else. Right, so it's, are we working with a proportion or a mean? I think that's the most important thing. The second most important thing is, what is the question? Like, what are you being asked to do? And here we've got a bunch of different things that you've been asked to do. Really, this is, I shouldn't say chapter 10, I should say the final exam. This is really chapters 8 through 11 is what it's going to be. And we're going to add one more thing after the parameter before we do what is the question. But we have to do chapter 11 first. So the options here, there's the verify, ... Verify the conditions are met to construct the confidence interval, to perform the hypothesis test. That is just a chapter 8 set of conditions that also showed up in chapters 9 and 10. And really, they're slightly different based on confidence intervals or proportions, as confidence intervals or hypothesis tests. So be mindful of that. The second one is, the second one we did, if we did this in order, is construct. ACI. The third one we did was the how many. And remember, there were other ways these questions were asked. Sometimes it was estimate the minimum sample size. So maybe it'd be helpful to add into these kind of the other things that could be asked. And then finally, we did perform the test. It was like test the conclusion. Test the conclusion. Or the claim. Maybe let's say test the claim, which is a hypothesis test. Okay, so I mean, I think if you can nail down these two things, the rest kind of falls into place. But the other things you need to do then is, what do you find what you know. So when we're identifying the given, it's going to be the statistics, right? So that would be N for sample size. That would be X bar and S, or a P hat, etc. Okay. I guess there aren't extras on that. It's just that. And then maybe number 4 is like, what technology do you need to use, or what formulas? So we'll just write formulas and or StatCrunch. Remember, when you're doing the how many, StatCrunch isn't useful. You just type it in Desmos. You figure out which of the formula are you using, put in the substitute your stuff, and StatCrunch it out. And maybe I'm breaking these into too small of parts. I guess write it up. Write up your results. So these are like the kind of 5 things you have to go through in order to answer the big questions, the big kind of all-encompassing questions. And they all start with, do you know which of these 2 you're working with, proportion or mean? And if you remember way back in chapter 3, we talked about parameters and statistics and the symbols and all that. And now we're putting this all together and mixing it up in a nice bag, and out comes beautiful ice cream. So I want you to try this with, I'm just going to throw a problem at you. I'm going to grab it on chapter 10, the 10 review, and you're going to run through and try to figure out what you have to do and solve it. Does that sound good?
Yes, I appreciate you writing that out again. I just took a picture of it with my phone.
Okay, nice. And like I said, we're going to add one more in here, because when we get to chapter 11, we have to decide, is this 1 sample, which is everything we've been doing, or is it 2 sample? So one more little piece that gets added in. It adds a little more complexity, but if you've got this part down, the next part should be okay too, hopefully. It shouldn't be too much. So let's go to chapter 10. Let's go to page 704. Let's go to page 705. All right. So let's do no. That's it on chapter 10 review. Just those 3. Wait, am I looking at the wrong one? Chapter 10 review worksheet. Nope, I'm not.
That's it, Eric.
That's it. Man, we pared this down, didn't we? Okay, let's go to 705. I'll give you 5 minutes. You see if you can do it. Set a timer for 5 minutes. See if you can't figure out A and B, or really figure out this stuff. You don't have to solve it, but get down to step 3 in this part. Okay. How'd you do?
I've got about 800 papers laying in front of me.
Nice. Well, let's just talk through the part, to me, the important part. And that is number one, is this, what's the parameter? Mean or proportion, and how do we know? How do we know?
Proportion,
How did you know?
because it doesn't say average anywhere.
I said proportion because the 30%.
That's it. Both of those are great things to look at. We've got a percentage here, 30%. This, whether it makes sense or not, this is a percentage, 1/3. It's a 1 out of 3. So yeah, this is a P. What are you being asked to do here? Confidence interval, verify the conditions, blah, blah, blah. What's the big question you're being asked? I get, so maybe I should note, here's the verify the conditions part, right? So this is a C1, a C2, and a C3. What is part C asking you to do?
Steps 1 through 6.
That's it. Hypothesis test. Nailed it. Okay. I forgot chapter 10 is only hypothesis tests. So this is a proportion hypothesis test that includes a verify the conditions. Let's go back here to page 704. Let me give you 2 minutes. And let's just determine what parameter. Maybe we don't need 2 minutes. I'll do a minute.
We're just doing page 104 real quick.
Yeah, 704. Just tell me what parameter. What do y'all think? What parameter are we working on, and how do we know it is that parameter?
Well, it says the standard deviation and the average length. Yeah,
Go ahead, keep going. So which one?
so it's a mu. Or
Nailed it. And then this one, here are the requirements for conducting the test satisfied. C1, C2, C3. Test your claim. You're being asked to do a hypothesis test for a mean. So this was not what I had in mind that I wanted to think about. Let's jump down to, now I'm really going to blow your minds. Let's jump down to the sample final exam. So I want to go to page . Go to page 752. And I want you to read question C and tell me the parameter you're being asked to work with and the question you're being asked to solve. So I'll give you 3 minutes on this one. So just a reminder, this is page 752. And I want to know, what parameter are you working with? Parameter. And what question? Those two things. 3 minutes.
My mind can't get away from the hypothesis tests, so I'm pretty lost right now.
Okay, let's try something new today. In the chat, there's an option where you can send a message just to me. So click my name in the chat and type in your answer to the parameter. So if you think it's a mean, type in mu. If you think it's a proportion, type in prop. And that way you can send me an anonymous answer of what you think it is, and then I'll know that everyone's tried it. Also, let me know who here. Yeah, okay. All right, and then second, tell me, what question are you being asked to answer? Good. Someone already told me the question that you're being asked. And then so nice. Love it. Okay. Good, y'all. So those that respond to the chat are telling me that we're working with a proportion. How do we know? Not because of this percent. This is the confidence level. this margin of error helps. That does it. The other thing is the word back up here. It said proportion back up here. And then the question that I'm getting in the chat is the how many. You're asked to calculate a sample size. So you can run through and solve that. Bam, done. So to me, this is what we've been doing is putting in all the little pieces individually. So we taught you how to do a proportion confidence interval, a proportion, a mean confidence interval, a proportion hypothesis test, a mean hypothesis test. And you've got those 4 things floating around. There's requirements that need to be met in order to do these different things. And then maybe we want a specific sample size to go with a confidence interval. So all of that is swirling around, and hopefully you know each of them individually. And then when the final exam comes, you're going to have questions like this, where one after the other, it's do one of those 10 things that we just taught you how to do individually, but they're all swirled together. So keeping track of the clues of what do you need to look for to know that we're talking about a mean versus a proportion. What is the question we're being asked? To me, is the ultimate skill. Now, if you don't know how to do a hypothesis test from start to finish, right, that's a problem that we need to fix. But the ultimate level is being able to do all of that and figure out when to do all of that. So you still have some work with the chapter 10 review to do. We've got 5 minutes left. What I think I'd like to do is just stop here and give anyone a chance to ask any questions on the chapter 10 review or on anything. You have these 2 worksheets that you're turning in. And tomorrow, Cindy, what are you all doing tomorrow?
We are starting chapter 11.
So what happens tomorrow is you do all of this again, but with 2 samples. So I want to say, don't be scared of chapter 11, because it's just confidence intervals, hypothesis tests, and sample size calculations, but we're doing it with 2 samples and comparing them. So all that is really different in chapter 11 is there's one more requirement added to the testing thing, and then step 3 and step 1 for hypothesis testing. Confidence intervals, same thing. It's just one more requirement, and actually you have to do all of these twice, which is kind of annoying. And then what you do in StatCrunch, a little bit different. That's it. So awesome, great work, you all. I hope it's feeling good. I think we're gonna have plenty of time to get through, like let you experience chapter 11, and then just practice, review. Congratulations, you basically know everything you need to know for the final. Almost. We just need matched pairs and independent sampling.
So just to remind you guys, I sent your assignment sheet for this week, last week. So you have your week 14 assignment sheet that I sent with week 13.
Okay, I'm gonna end this then. For once, we're ending 3 minutes early, I guess.
I know, you'll be on time.
Yeah, right, I guess. And then I was late. So, okay, so maybe we should go 3 minutes late. No, I'm just kidding. You all have a great evening. I'll see you all on Wednesday.
I'll see you tonight, Eric.
Sounds good, Cindy.